Hey guys, good morning. We'll give just a minute or two to let people join from the Discord, and then I'll introduce Theo. Theo, how's it going?
Hey, doing all good.
Awesome, awesome. Cool. Well, it's being recorded. I'll go ahead and just kick things off, and then let people join. But yeah, good morning, GM, everyone that's joining us, and everyone that's checking out the recording. And welcome to our first NoirHack library workshop, which is focused on the ZKPassport SDK. So I'm super excited to introduce Theo from ZKPassport. He'll be guiding us through this session. So what makes today particularly exciting for this workshop is it represents the first unveiling of ZKPassport's on-chain verification capabilities, something that isn't even documented yet in their official materials. You'll be getting an exclusive first look at on-chain verification with ZK Passport. So ZK Passport leverages ZK proofs to enable privacy-preserving verification of passport data. So this allows for a bunch of interesting and cool use cases for verifying important information, some of which we'll get into and explore with Theo today. So he'll walk through the SDK and how it works. He'll demonstrate some of the functionality and then showcase this on-chain verification for the first time. So Theo, I'll let you take it from here. Cool.
Well, thank you for the intro, Rafi. So as Rafi mentioned, so we're using passport and ID card to essentially verify information about you. Now, what kind of passports? Essentially, like this one. Actually, you can't see. Oh, you can see it. So this is a regular passport. It also works with ID card as well. So something like this, if you can see it, I think I should deactivate my blur, but unfortunately, you can see the gist of it. So it's all kind of documents, identity document issued by government. Your government probably issued something like this, and that has a chip in it, an electronic chip. So you can leverage this because this data is signed by the state. So information about you, such as your name, your birth date, your document number, any kind of information you can see on it, and some other stuff that's also hidden inside your chip is signed by the state. So what we do is that we leverage this and we verify this within a zero knowledge proof using Noir. So all of our circuits are built using Noir, and all the verification is done within Noir circuits using Brattenberg, the backend of our stack, to generate the proofs. I'm gonna share my screen. It should be easier to present that way. All right. So just to showcase, I cannot do a proper demo. It's a bit harder to do with the app. But the idea is you would take your phone. Actually, let me deactivate my blur because like this is going to be annoying otherwise. So where's that video? And there you go. Oh, much better. There you go. So you would take your phone, like any kind of phone. Most smartphones nowadays have NFC capabilities. Those chips are NFC enabled, and you would just put it behind your phone and it would read the data with that app. And same thing goes with passport. Same idea. And so here with the app, you can see everyone can see my screen. I didn't ask, just one confirmation.
Yes. Yeah. Yeah.
Okay, cool. So here you see that's the screenshot you would get in the app. So when you start the process, you scan what we call the MRZ, which is the machine readable zone. So those two lines of information, like numbers and letters at the bottom of your passport, will contain all the information to decipher the information and authenticate with the chip of the ID. So once you've read that, all this is done locally, you will move to the next step, which is scanning the actual ID with your NFC capability. And then you would eventually have them in your app. And now we also added a new feature where you can have several IDs in your app at the same time. So for example, this is for mine. I have both my national ID and my passport in it. Both of them works. So this is the general idea. The overall standard is not permissioned in the sense that state controls it. It's like more like a not fully permissionless, but somewhat permissionless standard, which is set by the International Civil Aviation Organization, the ICAO. which is a subsidiary from the UN, United Nations, and then the one that kind of set the standards, and the states have to follow them. Sometimes they don't respect all the rules, but that happens. But most of the time they do. And so the core idea of like that idea of signing the data is that the passport is signed by the intermediary certificate, which itself is signed by the root certificate. And what we have at ZKPassport is that we have like this certificate registry, which contains all the certificates from most states, and that we're able to prove essentially that your passport was signed by one of them. And by the way, by that process, we have the trust anchor being the state. So this is a pretty strong assumption if you trust your government. Not all government as trustworthy as all the others, but most of the time you can. So this is the general idea. Any questions so far? Before I move on to the more tech side of things.
For anyone with questions, you can ask in the chat. You can also just ask in the Q&A.
Okay. Good. Well, I think I'll carry on then. Just to show, before I move on to the tech part, so this is the map of all the countries that issues electronic passports, sometimes called biometric passports, so essentially passport or national IDs with a chip. So it's a pretty good coverage. Now, not in every country people have passport, but if you take, for example, the EU, you must have at least one national ID or passport, and national ID are all transitioning to electronic now. So that's the joy. So how to use the ZKPassport. I'm going to show the little demo here. And this is available on demo.zkpassport.id. Oh, actually, if you want to get a head start and download the app now, because you will need to essentially try out the tooling, you can go on the website, zkpassport.id, and click the download button and scan the QR code here for iPhone and here for Android. So I'm not going to leave this on because I want to move on, but you can go on zkpassport.id. And so on demo.zkpassport.id, which you can access from the main website, for example, I would open this, and I can scan with my phone, and that will initiate a connection. Wait, let me just switch to my other ID actually. Yeah. All right. So that will initiate like a end-to-end encrypted connection, WebSocket connection between the phone and the website. And you click on confirm, and it sends back the proof to the website. Let me just open the console logs. Oh, it got lost. The WebSocket again got dropped. So it proved that I'm over 18. So what you see here are all the proofs. So this is what we had until now, and it's still available here. It's pretty fast. It takes a few seconds. So this is what we call the fast mode. So you get all those proofs. So those two proofs verify the signatures, your passport data. This is the data integrity, so checking the integrity of your data. And the final one is the disclosure proof, essentially here verifying that you're over 18. So those are 4 different proofs, but they're all linked together using commitments. And then you can get the result here. See, can 18 over 18, yeah, that's true. And then unique identifier here, which is also returned. This is essentially some kind of identifier, which we sometimes call nullifier, but we call it unique identifier here, which identify uniquely your ID. So this will be the same for the same ID for the same website. I will come back to that a little bit later, but this is the core idea. So if we go to our docs, to integrate ZKPassport, it's pretty easy. Like, you just install our npm package, you run this, and then you can import it. And there's no registration, no API key whatsoever. This whole process can be done without any other process, any other sign up. So you import the SDK, you can set it up here with your domain name. So this is important because essentially this will scope what I mentioned before, the unique identifier to your domain name. So that way they're not the same on different domains. So there's not like cross-reference and trying to essentially track people across different websites. And if you do this in the browser, you don't need to specify it because we can automatically detect it. But if you do this in Node.js, you need to specify it. And then you can build a request. So this request, you specify here the name of your app, the logo of your app, the purpose, what you want to do with that information you're asking, and the scope. You can specify it or not. This is optional. This is even more scoping on top of the website domain. It also scope to a specific use case. For example, if you want to have an identifier which is specific to a use case. And what it will look on the app when the user scan the QR code is this. So you have this access request page, will show your website name, the domain name, the logo, and then the information that you're asking, with some information that user can see, and the purpose at the end. And they can accept or confirm. And once you've done this, you got a query builder, and you can use that to simply disclose the information you want. You disclose your first name, you check that you're over 18, you check you're within a list of countries, like your nationality is from a list of countries. Here we have some constant, like EU countries, for example, 27 countries, and you check that you're outside of certain countries, such as Sweden, Denmark here, just using for the example. And then you can use the URL, which is return, to build a QR code, or directly build a button or a link the user can use to click on if it's directly using your app on a mobile phone. That way, it redirect him or her to the mobile app to do the rest of the process. And we also have a bunch of events you can use to follow the process. So on request received means that the user scanned the QR code and he has received the information on his website, on his phone. Essentially, he sees that page here that you on the screen, and then generating proof. Essentially, says that the user confirmed and is currently generating the proof. On proof generated, it means that the proof was generated and that you're starting to receive them. On result is when you actually received all the proof and you receive the final result. And on reject is if the user actually decided to reject the proof, the request. And on errors, if you have any error during the process. So I will show quickly how this all plays out with our SDK example. So I have it running, actually, I'm going to show it here first. I have it running here. So this is similar to what I've shown before. I scan the QR code. You can see request received. So the request received event was called. So you know when the user actually scanned the QR code, then you confirm. They confirm on the phone, generating proof, and then proof received. It's pretty fast. And then you get back the information. So first name, EU citizen, is over 18, the unique identifier, and then verified, yes. So you can see all the information again in the console as well, with all the proofs. So how it looks like in code. So for example, here is ZKPassport SDK example, which you can find here. So it's on our GitHub. So GitHub/ZKPassport/ZKPassport-SDK-example. I'm going to send the link in the chat.
One quick question, Theo, in the chat about the SDK. Is it only for JS? And is there any other language support?
So the SDK is for now, it's only for TypeScript. So this is only a TypeScript SDK on the JS. So yeah, no Rust SDK for now. All right, so I've sent, wait, not an API. No, you don't have a generalized API in that sense, because you need to communicate with the WebSocket. It's like the TypeScript SDK is a wrapper around it. So all right, so this is how it looks. So this is a React simple app integrating our SDK. You can see it's imported here, and you initiate ZKPassport here. It's using the host name here, so the domain name of the current website, which is localhost, since I'm running it locally. and then you build your current request. So here's ZKPassport, the logo of ZKPassport, proof of your citizenship, the scope, and the mode fast. So by default, the mode is fast, which means it returns the subproofs. It takes a few seconds. And then you got the query builder. You build your query, you call done. And when you call done, then you can get the URL and all the callbacks, and then you can use that to update the user interface. And on proof generated, you can get the proof, which is proof result. It contains the proof, the key hash, some other information. And finally, the result, where you will get the result of your request. So first name disclosed, and the result here, which is the actual first name. Or when you have a comparison, such as whether it's within a list of country, it will return a Boolean saying whether it's true or false. And that's essentially what you see on the website here. That information has been used to display the result. And yeah, and the QR code is a simple, like React QR code library you can use to, you just put in some text, it's going to be the query URL, and you have a QR code. Any questions so far?
We've got a few. It's up to you whether you want to answer some of them now or at the end. If you check the Q&A.
Oh, Q&A, where is it? There, got it. So yeah, I'm gonna answer some. So technically speaking, what was your main challenge you faced using Noir so far? Well, we started using Noir when it was still pretty early. It's like I would say version maybe 0.2 or even before that. And there's been a lot of breaking changing on the way, so there's been challenging to update the circuits as it go, as every update come. So they would break stuff and we need to change it. So it would make the process of like building a little bit longer, but now it's a bit more stable, so it's okay. At first, the performance of Rattenberg were not as good, but it's been severely improved and now it's doing pretty good. So that was also a main challenge we faced. And otherwise, it's definitely much easier than using Circon, that was for sure, even if we got early on the boat when it was still like very early language. Also, probably the lack of existing library, which is why we built like a bunch of library to build our whole tooling and circuits. Is it being used by any commercial entity or country yet? As far as I'm aware, not really. We only have been used, so we have been used by DEFCON for the ticketing, the discount back in November. So they run like a discounted ticket sale for Southeast Asian countries. And so people that would prove they're from those countries, they would get a discounted price for the ticket. So that's one of the integration we've been used for. Otherwise, a lot of people have been waiting for our on-chain use cases, our on-chain like infrastructure to be ready in order to use us. So I think that now we've just finished it or close to complete finishes because there's some refinement to be made as I think it's going to become more and more integrated, more a commercial entity. As for country, not really. I mean, being integrating by a whole country, that's another subject. I did have opportunity to speak to the French government for age verification, but not really integrating anything. And the last one, please, what did you guys use to build the mobile application for ZKPassport? I'm just curious to how to use Noir with the mobile application SDK. So we use React Native for the app, like many others. And we have built a whole mobile proving tooling, which is called, well, there's several components to it. There's BBRS, NoirRS, which can be used not only in mobile, but we optimize it for mobile, which itself is used in Swar, which can be used with Swift on iOS, and Noir Android, which can be used with Kotlin for Android. And all this is plugged back into React Native through the native module. So that's something that's open source, which you can use. So actually, let me show it. So if I go in ZKPassport, and I should be able to see NoirHack. So this is what we use at the core. So it allows you to generate proof with Rust. And we use that on mobile. And the way it works is that we wrap this in the library called Swar, which is also open source and free to use, and allows you to essentially generate proofs in Swift, which again, we plugged into React Native. And for that, I do have a template that I probably need to update to the latest version, but still not too old. The Noir React Native starter. So if you clone this, you can have like a good way to start to see how to generate proofs with Noir and Bratenberg on mobile, both iOS and Android. Yeah, so I'm gonna stop now and we'll continue later with the questions. Hope that answers everyone's question so far. All right. And so in terms of use cases, so you have some example in the docs. You can verify the age, for example, verifying you're over 18 or between an age range, 18 to 25, your nationality, checking that you're from a given country or list of country, or is not from a list of country, even residency. So for example, let's say you want to prove your residence of France, you can use some residence permit in Europe mostly. They also use the same standards, so that can be used for that. As for the topic of personhood, you can have some kind of proof, but it's more one ID, one account. So it's not perfect personhood, but it does increase Sybil resistance because you don't have that many IDs as a single person, generally 2 or 3 maximum. Like I have 2, for example, a national ID and a passport. So you can just not query any information and just send the request to the user, and you will just get the unique identifier and all the information, and that will be enough to have like more Sybil resistance. You could use it for basic KYC, but for now there's some element missing to have like full KYC. And we have like here an example to do like client-server interaction, but you can look at it later. I'm not going to go over that. And the new thing that we just added, so we've been working on this for the past few weeks, is on-chain. So it's not in the docs yet. On-chain interactions, on-chain verification. So what that implied is that instead of having all those subproofs that you've seen, those 4 or 5 subproofs, we recursively verify all of them into a single proof. So it's compressed into a single proof that you can verify on-chain. You only have one verification to make, which is way less expensive than if you would have to verify all those subproofs. So this new mode has just been introduced. So I'm going to present it for the first time. And here's an example. So I already done it. You're going to have to bear with it when you do it, when you try it with the mobile app, because it can take a little while to generate the recursive proof. This is done through a server, which is not yet quite optimized for like extreme speed, but we may like improve that later on. But the main idea is that instead of having all the subproofs, you only have one here. Here you can see there's only one proof, and that's verifying all the information you can see here. So this can be used on-chain. And the way you do it, so I have the example here in the EVM folder, is that you replace the mode fast by compressed EVM. And when you do this, the app will essentially send you back one single proof optimized for EVM verification rather than all the subproofs. So this is primarily that. And once you have the proof with the on-proof generated, you can use our helper function from the SDK, get solidity verifier parameters. You pass it the proof, like the proof result. It will answer with all the parameters. And then you can also get the details of the verifier, which will give you the address in the API, and you can feed that into Veeam or Ethers.js, and you will be able to interact with the smart contract. So this is how you would interact. Now, behind the scene, the SDK verify this proof directly on chain. If it's not a compressed EVM proof, it will verify it with BBJS behind the scene directly client side, but in this case, it will verify it on chain. But here you can do it manually if you want as well. Yes, deployed on Sepolia. But now we're gonna keep with testnet as we refine the smart contracts and the certificate registry and circuit registry as well. There's a few other things we need to build, but like people can start building with Sepolia. That's actually there's a for people looking for a first faucet. I've discovered that Google has a faucet for Sepolia. It's actually pretty reliable, so you can get some testnet ETH over there. So I think that pretty much covered this part. So this is the SDK. Now, if you want to do interaction directly in a smart contract, so I'm going to show how the verifier looks like. So this is a verify proof function. This is all the parameters that were returned by the SDK. So you don't have to worry about what they mean. The SDK will just provide everything for you and you feed it into the function and they will return whether the proof is valid and also the unique identifier. So how we use this in another contract is an example. So you can find this, I'm going to send the link actually. So it's in our repo, circuit repo on GitHub. If you go into source, Solidity, source, sample contract, let me send the link. All right. And so this sample contract here, wait a minute, wait a second. So this sample contract here as an instantiation of the ZKPassport verifier, which you can instantiate here. And the idea is you would register the user. So you take the generally like the parameters necessary for the ZKPassport verifier as parameters. This is another Boolean which indicates whether the user is using an ID card or not. This will be useful for the disclosed information. And the idea is that you call the ZKPassport verifier, verify proof function directly within your smart contract. You get the Boolean whether it was verified and the unique identifier. You check that it was verified. And then you check whether the user was not already verified. And then you have a bunch of helper functions provided by the ZK verifier, the ZKPassport verifier, which allows you to extract the information you're trying to verify. So you have here, for example, an age proof, which is contained in that proof. So you extract the minimum age and maximum age. So here you check that the current date is not in the future. So that, for example, it's not a date that's been invented. And you check that the mean age is 18 and the max age 0. When the max age is 0, it means like it's ignored. So essentially it's like as if it's inexistent, no bound. So here it checks the user is over 18. And then you can get the disclosed bytes from I mentioned before, the MRZ, which is the 2 lines at the bottom of the passport. So that contains your name, your nationality, and all the kind of stuff. And then you'll be able to use get disclosed data to be able to format those data, and so you can get whatever information you want. So for example, you can get the name, the issuing country, the nationality, the gender, the birth date, the expiry, or the document number. And you have another one to get the exclusion list, for example, of country. And then you can run your check that, for example, here it's like checking whether the user is not from Spain, Italy, or Portugal. And once all the checks are run, you can set the user to be verified, store his nationality, and then associate the address of the sender to the unique identifier. So later, when you want to do stuff, you restrict port for register user only, since the unique identifier will be always the same for your domain and for a single ID. And you can also unregister as well if your user, for example, wants to change address and register to another address. So that's an example you can use to build all kind of like use cases on chain. But you will need the app remember to generate the proof so you can test things out. We do plan, but I can't put a date on that just yet, to have the ability to generate proof with mock data. So testing process will be easier for people that do not have an ID that we support. So, but for now, you would have to use like an actual passport or national ID that is supported by us. Any questions so far? Let me check the Q&A.
Just want to go to market.
Oh yeah.
Oh, another one.
Oh yeah. So go-to-market strategy. Yeah. And when it comes to this, ZKPassport is more like a public good, credible, neutral. So there's it's like a tool people can build stuff upon. We do plan to we do ourselves building stuff on it. Like, I mean, we're gonna do integration of this into Obsidian, the wallet on Aztec. We're gonna probably build some other stuff to if some idea come to mind, to kind of show people what can be built with it. But we do expect people to use it and not necessarily getting much benefit from it. Now, there's some things that we may introduce in order to pay for the infrastructure cost, but primarily the ZKPassport is a public good. So the go-to-market strategy does not really apply here with ZKPassport itself, at least the protocol. The unique identifier is different in every SOL contract. It's not really scoped to your contract. It's more scoped to the domain name, to the website where you generated it. So it's not, well, it's going to be different most likely, because like a different website will probably use a different SOL contract. But if two websites use a similar contract, then that would be two different. But if like, so you get the general idea here. It's like it's not according to your SOL contract. If a DAP A stores age and DAP B stores nationality, I could get age and nationality identifiers the same, and I know about the logic of A and B. That is if it was generated with the same website, essentially. So because the identifier would be the same for the same ID and same website, because the scope is scoped to the website. And on the app, what prevents someone to cheat regarding the domain name is that the user will see always what domain is requesting information. So if the domain doesn't match the one on the website, then there's something fishy, and then that will show up. In the SDK sample, how does it relate to Noir? So the fact is, all of our circuits are built in Noir. So you could use the proof in Noir technically if you use like the fast mode or the compressed mode, but not the compressed EVM mode. But all of our circuits are built in Noir. For example, here's like the age circuit. So this is a circuit in Noir, or you have like the signature checks. And if any of you actually needs to do ECDSA verification or RSA verification in your project, you're free to check our library for that. So we have Noir library in order to do this, Noir CDSA. So if you want to check anything else than SecP256R1 or K1, you can do that. We have implementation for most NIS curves and most brainful curves, which we need for our passports. So we have like all kind of tooling you can use for Noir, but like our own circuits are built in Noir. That's the main idea. Thinking of using driving license as document. No, we are not, because this is an entirely different sender. So that's something that's to be handled differently. There's a few projects that have been working on this. I can't quite remember the name, but it's completely different. And are working on something like proof of innocence. So we do plan to have some compliance in Obsidian, but that's beyond just what ZKPassport can provide, but ZKPassport would be a base for it. And just not innocence, is just general proof of compliance is a bit more involved. Scalability, that's still to be addressed, to be honest. We'll kind of see this through as people use more and more. And what I mentioned before, infrastructure cost, because obviously scaling will cost money. It's not, we can't make everything for free. We'll provide people the ability to plug their own WebSocket into the SDK so they can use their own infrastructure by using our code. But by convenience, we also have like some own WebSocket that people can eventually pay for. But like we're gonna always allow people to use their own infrastructure, like not pay for ZKPassport and like pay for their own thing. But we're gonna provide some tool convenience because we got to essentially be able to pay for the infrastructure as more and more people use it.
There's one or two questions still in the chat from Heike, which I saw Michael answered part of, but they're asking, what are you missing from being eligible as KYC, if anything? And then also just wanting to understand how it's verified.
What do you mean? How is verified?
Oh,
Oh, yeah.
she's asking, can you fake it?
Oh, faking it is very hard. You will need access to the private key of the state. I think the only people that can fake it are the state themselves or like intelligence agency operatives. They probably have access to the private key, or like, for example, some kind of agreement between like rogue nation states. Like, for example, I think it would be possible that in order to evade sanction, North Korean intelligence operatives would have a passport signed by the Chinese state. That could be something I could think of. But beyond that, beyond state actors, you don't have to worry too much about issuing fake passports. Like, as long as you trust the cryptography, and as long as they're not using SHA-1, which is unsafe. But actually, there are some states using SHA-1, like Russia. It should be all right. Like, as long as the signature algorithm is secure, you can trust it. Regarding KYC, what we're missing to be eligible. So for KYC, that's something we plan to, a feature that we plan to add is face recognition. Face recognition, so you want to match the photo, which you do get from the chip, of the passport or the national ID with the video of from the camera of the phone from the person that's actually generating the proof. So you want to prove that they match, and you want to do a liveness check. So someone is not trying to stick a picture in front of the camera of someone else. So you need to do this kind of check. And we do plan to have this. And once we have this, this should be pretty much enough guarantee for KYCs, basic KYC. I'm not talking about AML and CTF. Those are different stuff, which you'd need in case of like financial transactions. All right. I think I answered all the questions so far. So to summarize, if you want to start, the ZKPassport SDK is available on NPM. You install it, and you can just use the SDK example that I've shown as a base for getting started with the SDK. And then you can look, I think it's been sent before, yeah, to the sample contract on the repo in order to see how to interact. As for the address of the verifier, the SDK will essentially give it to you. So you just call like get solidity verifier details, and you will get the address in the ABI, and we'll update the address if it ever changes. So you don't have to worry too much about that. The SDK will provide everything for you. Oh, there's another question. Do you have selective disclosure? Yes. So selective disclosure is essentially, let me show the code. Selective disclosure is this. So disclose function in the SDK, you can disclose all the kind of information you can get from the MRZ, you can disclose it. So for example here, birth date, document number, document type, expiry date, first name, full name, gender, issuing country, last name, nationality. This is all the information you can disclose specifically from the MRZ. All right. I think that answers it. So I think, yeah. Otherwise, I don't need to get too much into the details, but like that's the mobile app. Does everyone know how to access the mobile app? Actually, let me just share the link just to be sure. I'm going to share the test flight link. There's also an Android version, but for that you will need to go through our registration form. And then we add you to the list of closed testers on Android. It's an open beta on iOS, so it's easier. So you need that, the mobile app, and then you can use with the SDK, and you should be able to try it out. And then you can use the SDK to get the parameters you need for the verifier on Sepolia, Ethereum Sepolia. And we open to feedback. If you've found any bugs with the app, we're not supporting all the documents. Some documents may be a bit buggy, because sometimes there's unexpected data formatting. So we open to feedback so we can improve these things and fix the issues you may be encountering. And yeah, I'm thinking about the channel where you could do that. I'm not very active on Discord, so I'm trying to think where people could like send me back messages. I guess, yeah, pinging me on Discord might work. Yeah, I will receive notification. My pseudonym is just the same as here, Madzou, so I can send it here. And if you tag me, oh, sorry, I should be able to answer on Discord. Well, I think that pretty much covers it. Unless you have any other questions. No. Yeah. I think that's it. Yeah.
Awesome. We can take some more questions. So Theo, is there anything else you want to walk through? I can also ask you maybe some more questions.
Yeah. You can go ahead, I guess.
Yeah, maybe you could share more about your roadmap for expanding like types of verifiable passport data. I know there's like different standards and ways in which you support current passports. It'd be interesting to hear how you guys are thinking about that.
So the challenge with supporting different type of passport and national ID is like about the different type of signature algorithm that are supported. So we support and also hashing algorithms. So we support like a bunch of them now. So states are allowed to use ECDSA or RSA, and they can use different parameters within this realm of like two signature algorithms. So we need to be able to adapt to all those in order to support all the documents. For now, I wouldn't be able to put an exact number on what we support in terms of document, but we support, though, in terms of signature algorithm, we support RSA, nearly all of them, except like some really unusual exponents, but we'll detect them along the way as we get feedback. And ECDSA, we support most brain pool and NIST curves with SHA-256, SHA-384, and SHA-512 for the hashing algorithms. The main issue may be that some documents use SHA-250-224, but that's something we can add support to. Shouldn't be too difficult because you can derive this from SHA-256 implementation. The other issue might be SHA-1, but we are wondering about SHA-1 because SHA-1 is not secure. So you're making a proof of a hashing algorithm which is not secure. So we're wondering whether that's worth it. But there are some countries that still use it. As I mentioned, Russia, also Lithuania, I think there was either Spain or Italy have some certificate that still use it, but it's insecure. So you're making a proof of an insecure stuff. So I'm not sure. So the roadmap on supporting mobile passport is depending on this, but also the mobile app and its ability to read properly all those and interpret the data properly, because sometimes when we read the data, it's not formatted as we expected, and it's very hard to test because we don't have access to all the passports in the world. So we kind of like flying blind, expecting people that encountering issues to tell us enough information in order to debug it. Because since we are privacy first, we can't collect any information unless the user actually wants us to send it to help us debug. So it's flying blind, which is kind of tricky. Unless we fly everywhere in the world and trying to get a passport from each country, that's or like sometime at conferences that can be useful since there's a bunch of people from all around the world. As for I think the roadmap clearly for the next few months is going to be refine the on-chain verification to have the certificate registry, which is nearly ready for now. It's like a static registry, but we're going to have a certificate registry that's going to be automatically updated by pinging the ICAO registry. So the ICAO is like maintaining a registry of all the root certificate from different countries. Germany also has one. The Netherlands also has one. So we have like Michael, my co-founder, has been working on this. Something that essentially downloads all those on a regular basis and updates it as its new certificate are added or removed. So it's going to be automatically managed. So we're going to have like a more lively certificate that's going to support all the latest issue documents. So that's also going to have broader support with this feature. We have the circuit registry that we need because we want the proof to be generated only by the circuit that we recognized, because the circuit can be uniquely identified by its verification key. So we're going to use that to prove that when you generate that single proof that you verify on chain, that it is part, it was all the circuits that were used are part of the circuits that we know are from us. So that's something we're going to set up too. And then you're going to have the face recognition feature. We're still thinking about how we're going to go about it, but we start to have like a pretty good idea. And we're also going to need to have Aztec contracts to manage the registry on Aztec, so people can use the proof on Aztec. So just slight note regarding Aztec: if you want to use the Aztec, you want to verify the proof on Aztec, you need to use either the fast mode or the compressed mode, but not the compressed EVM one. The compressed EVM one will not work on Aztec. This is optimized for EVM. The other two will work. Recommend the compressed one if you want to have a single proof. That's just a bit longer to generate on the phone. So we have to have all that registry, kind of like similar thing that we're doing on EVM, but on Aztec, but it's going to be easier than EVM because it's more optimized for the kind of things we want to do. And what else would be on our roadmap? We have some exciting, cool ideas of product we want to build. That's also something we have on the roadmap. So it's things people may want to use, like things notary lawyers or like compliance officers will want to use. Real things we can build with ZK Passport, like setting an example of real products.
So
And
in
I
that
think
same
that's
vein,
pretty much it.
maybe
Yeah.
for like some of the examples of cool things you'd want to see built, what are some simple examples you can think of that you could build with the SDK? Doesn't even necessarily have to be with related to like on-chain verification. It could be also just basic examples leveraging some of the things that you showcased in this demo, like that's on the screen now. Or if you have any ideas of cool things you'd want to see with on-chain verification, that would also be good to hear your thoughts.
So in terms of on-chain verification, like a pretty important use case I can think of is like nationality verification. If you want to essentially prove that you're not from a given country, because sometimes you have like extension countries or you have like countries which are not always good to interact with, such as North Korea, for example. So you may want to use that to build like, for example, region restricted airdrops, because some jurisdiction where it's not, people should not use it. So you restrict those to the region that are allowed. Or as for age verification, which is a pretty important use case off chain, on chain, I'm like still trying to figure it out, but you could restrict access to gambling platforms to over 18 directly on your smart contracts. So that way, that's kind of products that are generally meant for over 18 to adults can also be restricted on chain to only adults and not children's. We you remember like there was that was nearly a year ago. That was when ZKPassport didn't have all this tooling, and that was very early on. So we had like a very makeshift implementation, but we built that fun little project called Cone Hub that was around age verification. That was a play on words as for a website with a similar name, but with one letter difference. So the for that kind of industry, there are also use cases for the adult content industry. But as for on-chain, maybe I've heard of some project of like Web3 OnlyFans, but I don't know how that's going. But I'm not the kind of thing I would use. But if you can think of something like this where you would need to restrict age on chain, then it might be useful, yeah, as well for that.
So in
And
that, continuing that thread, maybe you could talk about like just how to think about proof generation time, and then like what are maybe some common mistakes that developers should try to avoid. I think like proof generation time comes to mind maybe as something that should generally be thought about with Noir proofs. But what are some things that like in using this SDK are important for developers to consider to ensure that they build like a clean like UX and like an actually usable app?
so in terms of proof generation time, so the more information you're going to request, the more time it's going to take. So the way ZK Passport works is that you're going to have different proof generated depending on the kind of information you request. So for example, here you have 3 proofs generated. The reason why is that this is one proof, the disclose. Those 2 requests, if you only add this, this would be one proof because this is disclosed by one proof. The disclosed proof is a single proof. But then you have like a proof for like inclusion, and you have a proof for comparison of age. So you have 3 proofs. The more proofs you ask for, the more data you ask for, the more proof it generates, the more time it will take. Now, for the fast mode, which is why it's called fast, it generally is not going to take more than 10 seconds, even if you ask a lot of proofs to generate. But this is something that's only optimized mostly for off-chain use cases. So with this, you can have like pretty good UX easily because it's pretty fast, but you're not going to be able to do on-chain. Now, if you switch to the compressed mode, that's where things gets a little bit tricky because this is much longer. It's still to be optimized, but I would say that right now, with the current instance of the cloud prover we have running, in order to generate that recursive proof, this is probably going to take a minute or 2 to generate compared to a few dozens of seconds with the fast mode. So this is why this fast versus compressed. And it's even more going to be the case if you ask too many information, because if you ask like if you have like those subproofs, if you have like 7 or 8 subproofs to recursively verify, then you're going to be probably more 3 or 4 minutes. So that's a bit challenging in terms of UX for now, for the on-chain use cases. We'll see how to improve that, but we're kind of severely limited by the recursion number of constraints in Baratenberg. As for the other issue now with I would say on-chain verification is also the Solidity smart contract is not quite gas optimized just yet. But now it's on Sepolia, so it's fine. But both the verification of the proof and maybe some of the helper function we have may consume quite a lot of gas, although for now most of the actual cost is from the verification of the proof. So that might be something that will be improved later. But that's just a gas issue more than a time. Although if you have like a very expensive transaction, it may take more time in the mempool to be confirmed.
We have one more question. It's related to another one. So someone is clarifying one that I had asked for more clarification on. And then I think it's the same person who's anonymous who's asking, like kind of restating that question.
Let me check. Oh wait, there's 2 function actually. There's 2 questions actually. What? Okay. If the mobile app is installed, the data is lost. I log in with ZKPassport. Probably I'm over 18. If I delete the app, or does my phone regenerate the proof would it map on my previous existing identifier? Yes, it would, because it's only depending on the ID and not the app itself. So yeah, if the app isn't installed and you scan the ID again, it's going to be the same identifier still. Now we're thinking about whether we should do registration or not with the secret, but that makes things a bit trickier for re-registrations. The idea of like registering with the secret comes from the fact that the unique identifier is only dependent on the ID. So technically, the issuing country would be able to track people because they are aware of the data that they issued. But apart from that, that's the main threat. Or anyone with your passport data, but you shouldn't give your passport data to anyone. What happened when you scan the passport then and install the app again? No, I think that's kind of related. Or is that pointing towards something different?
That's the same person who asked that. So basically, like Nicholas was clarifying a question, and I
Ah,
think it's
okay.
the same person. Yeah, I think they just asked again. They also asked anonymously previously.
Mm, yeah. And actually, let me show it in live. I'm gonna so I have two IDs on my phone and I can show that the unique identifier will be different. So I'm gonna switch. So here I'm using my national ID. So you have this one started with 507, and I switch to my passport. It's going to be a different one, like 174. And I mean, if I generate it again with my passport, it will be the same again. Yep, the general idea. One ID, one identifier.
Nice, awesome, cool. Well, I think unless there's any other final questions, we can wrap up. Thank you, Theo. This was super cool. And I mentioned in the Discord, if you have any questions specifically about ZK Passport, just mention ZK Passport explicitly and then tag me, and then also tag Theo. And then we will do our best to try to answer any questions about ZK Passport stuff. And just in general, if you have any questions about the program, feel free to tag me and I'm happy to answer. Cool.
Cool.
Awesome. Thanks, Theo. This was
Yeah,
great.
thank you.
Cool. Bye, everyone. Have a good one.
Hey, everyone. Thanks for your time.